Hello dear students, welcome to mathematics class. This is Prakash from Tunga Degree College, Jamkandi. In this class, let us discuss some more examples regarding groups. So here it is the first example in this video. Here, show that Q plus star is a group where star is the binary operation defined by A star B is equal to AB divided by 5. So here up to the last example, the binary operation was either addition or multiplication, but here instead of those two binary operations, here it is the new one, that star is defined by A star B is equal to AB divided by 5. So here we know that Q plus is the set of positive rational numbers and star is the binary operation which is defined as A star B is equal to AB divided by 5. So this is a quite new one, that A star B is not A plus B or A minus B or A into B. So it is AB divided by 5. So for this, let us satisfy all the 4 laws, that is closure law, associative law, identity law and inverse law. So the first one is closure law. Now for closure law, for all A comma B belongs to Q plus for any two positive rational numbers A and B, that A star B must be in Q plus. It implies A star B. So here A star B is defined as AB divided by 5, which is in the form of P by Q, where Q is not equal to 0. So here it is the numerator and denominator both are non-zero numbers. So therefore we can say that it is also a positive rational number, because A and B are positive means the product of A and B must be positive. So therefore this belongs to Q plus, then it implies that closure law satisfied. Closure law satisfied. Then second one is associative law. Associative law. So for the property of associativity, we need to consider the 3 elements. Let A, B, C belongs to Q plus. These are the 3 positive rational numbers. Now consider A star B star C. So it is the LHS part of that associative property, that is A star B star C. Means first we need to apply the binary operation for first 2 elements, then for the next one. So here by the definition of given binary operation, A star B is equal to what? AB divided by 5. So therefore it is AB divided by 5 star C. Now again it is in the form of A star B only. The first element is AB by 5 and the second element is C. So therefore A star B is equal to AB divided by 5, then it is equal to AB divided by 5 into C whole divided by 5. That is in the definition of binary operation, because A star B is equal to AB divided by 5. Here A itself is AB by 5. So therefore AB by 5. In place of B it is C whole divided by 5, and this is nothing but ABC divided by 25, because 5 into 5 that becomes 25 and the numerator becomes ABC. Then next RHS part of the associative property, that is A star B star C. Here first we need to apply the binary operation for next 2 elements, they are B and C. So therefore it becomes A star BC divided by 5, because B star C is equal to BC by 5, then it is equal to A into BC divided by 5 whole divided by 5, then it becomes ABC divided by 25. So here both the results are giving same value, that is ABC divided by 25, ABC divided by 25. Therefore, A star B star C is equal to A star B star C. Hence, associative law satisfied for the given set Q plus. Then the third one is identity law. Identity law. So, here the binary operation is A star B is equal to AB divided by 25. Now, let A belongs to Q plus, and the general statement of the binary operation is, the identity law is A star E is equal to E star A is equal to the element A itself. This is the general statement. But here it is given that A star B is equal to AB divided by 5. That is the given definition of the binary operation. Then we need to find the identity element for this binary operation. If the binary operation is addition, then the identity element is equal to 0, and if the binary operation is multiplication, then the identity element will be equal to 1. But here those two operations are not given. Here A star B is equal to AB divided by AB by 5. Then we need to find the identity element which will be satisfying for this binary operation, that is A star B is equal to AB divided by 5. For that, let us consider identity element E in place of B. So, therefore, here A star E is equal to what? The result is A itself. So, therefore, that is equal to A. Now, A star E is equal to what? A into E divided by 5, because the definition of star is like that, that is A star B is equal to AB by 5. Hence, A star E is equal to AE divided by 5, which is equal to A. Then it implies here we can cancel out the element A on both the sides, then we are remaining with E divided by 5 is equal to 1. Hence, it implies E is equal to 5. E is equal to 5, that 5 is the identity element for this given binary operation, that is A star B is equal to AB divided by 5. Then we are remaining with only the last law, that is the inverse law. Let us satisfy that inverse law. Now, the fourth one is inverse law. So, here let A belongs to Q plus, then there exists A inverse belongs to Q plus such that A star A inverse equal to A inverse star A is equal to E. So, this one is the general statement for the law of inverse. But here the binary operation is A star B is equal to AB divided by 5. So, then we need to find the inverse of A, means we need to replace this B by inverse of A. So, let us consider A star A inverse, the output must be equal to the identity element E. So, here A star A inverse equal to what? A into A inverse divided by 5 is equal to the identity element that we have found, that is equal to what? 5. Then A into A inverse is equal to 5 into 5, that is 25. Then A inverse is equal to 25 divided by A. So, therefore, this is the inverse of A. If you want to find the inverse of B, then that is equal to 25 divided by B. If you want the inverse of C, then that is 25 divided by C. So, like that each and every element of Q plus will have the inverses. Therefore, each element of Q plus have inverse. So, therefore, inverse law satisfied. So, here we have satisfied all the 4 laws. They are closure law, associative law, identity law and inverse law. So, therefore, Q plus along with the binary operation star is a group. So, here star is the binary operation which is defined as A star B is equal to AB divided by 5. Here star is not any multiplication or addition, subtraction, division. So, it is quite different. A star B is equal to AB divided by 5. The next example is in the set of real numbers R minus 1, means it is a set of all real numbers except 1. The binary operation star is defined as A star B is equal to A plus B minus AB. So, it is also the different binary operation A star B is equal to A plus B minus AB. Then show that R minus 1 with star is a group. So, here in the previous example A star B, that was AB divided by 5, and here A star B is equal to A plus B first element plus second element minus first element into second element. So, it is the definition of the binary operation for this R minus 1, means in this set there is no 1. Now, let us prove this example. The first one is closure law. Let A comma B belongs to R minus 1. So, here A and B are the 2 elements of the set R minus 1 which are not equal to 1, because in this set there is no 1, means these 2 elements are not equal to 1. Then it implies that A star B is equal to A plus B minus AB. So, here since A and B are not equal to 1, then this product is also not equal to 1. So, therefore, this belongs to the set R minus 1. Therefore, closure law satisfied. If the product of the binary operation A star B equal to A plus B minus AB, if that element belongs to the given set R minus 1, then we can say that closure law satisfied. If this element does not belongs to the given set R minus 1, then we cannot say that closure law satisfied. So, for this example closure law satisfied since this element is not equal to 1. Then second one, associative property. Associative law. So, here let us consider the 3 element A, B, C belongs to R minus 1, means no element of A, B, C are equal to 1, because the set is R minus 1 only. So, now consider A star B star C. So, here by the definition of given binary operation A star B can be written as A plus B minus AB star C. Now, it is also in the form of A star B only, where the first element is this total A plus B minus AB and the second element is C. So, therefore, here A plus B minus AB, it is the first element plus the second element minus first element, that is A plus B minus AB into the second element. Then it is A plus B minus AB plus C minus of, now multiply this bracket by C, that is AC plus BC minus ABC. Then it is equal to A plus B plus C, here it is minus AB, now multiply that negative sign into the bracket, minus AC minus BC minus into minus plus ABC. So, this one is equal to what? A star B star C. Now, consider A star B star C, means first apply the binary operation for second elements, that B and C. So, then here it is A star. Now, B star C means that is B plus C minus B.Sc by the definition of binary operation, first element plus second element minus first element into second element, that is B.Sc. Now, here we have the two elements, first element is A and the second element is this B plus C minus B.Sc. So, therefore, by the definition of given binary operation, that is A plus second element is B plus C minus B.Sc minus first element is A into the second element is B plus C minus B.Sc, then it is equal to A plus B plus C minus B.Sc. Now, multiply this minus A into the bracket, this becomes minus AB minus AC plus ABC. So, here look at these two results, A plus B plus C, A plus B plus C minus AB, here it is minus AB minus AC minus AC minus BC minus BC and plus ABC plus ABC. So, therefore, these two are one and the same. So, therefore, A star B star C is equal to A star B star C. Hence, associative law satisfied for this given set R minus 1. Then the third law is identity law. So, here 0 belongs to R minus 1, is it right? Because given set is the set of real numbers except 1, but 0 belongs to R minus 1. Now, if you replace the element B by 0, let us see what happens. So, here it is given that A star B is equal to A plus B minus AB, right. So, now here A star 0, this can be written as A plus 0 minus A into 0. So, therefore, it is equal to what? A only. So, therefore, A star 0 is equal to A, means it is similar to A star E is equal to A, in place of E we have 0. Then we need to verify E star A. So, for that let us consider 0 star A, 0 star A, that is 0 plus A minus 0 into A. So, it becomes A only, because 0 plus A is A, then 0 into A is 0. So, therefore, we are remaining with A only. So, therefore, 0 star A is equal to A and A star 0 is equal to A, means after applying the binary operation along with 0, the result will not changing, means the element A is remaining as it is. So, therefore, that 0 will be the identity element for the given set R minus 1, and that 0 belongs to R minus 1. If this 0 is not in this set, then we cannot say that 0 is the identity element, but here this 0 belongs to R minus 1, hence we can say that 0 is the identity element for this R minus 1 under the given binary operation star. So, therefore, A star 0 is equal to 0 star A is equal to A, it implies the identity element E is equal to 0. So, this is the identity element for given set. And the fourth one is inverse law. Inverse law. Let A belongs to R minus 1, then there exists A inverse belongs to R minus 1 only, such that A star A inverse equal to A inverse star A is equal to the identity element E. So, here we need to find the inverse of A. For that, consider A star A inverse. Consider A star A inverse. So, here what is the value of A star A inverse? That must be equal to the identity element, that is E, and we know the value of E, that is 0, and A star A inverse equal to, by the definition of given binary operation A star B, So, here A star B is equal to A plus B minus AB. So, A star A inverse becomes A plus A inverse minus A into A inverse is equal to 0, because the identity element is 0 only. Now, A plus, in these two elements A inverse is common, then remaining with 1 minus A, which is equal to 0. Then A inverse into 1 minus A is equal to minus A. By shifting this plus A to RHS, that becomes minus. Then A inverse equal to minus A divided by 1 minus A, or by taking minus common in the denominator, we can write A divided by A minus 1. So, here inverse of A is A divided by A minus 1. So, therefore, if you want the inverse of B, then just replace A by B. If you want C, then replace A by C in this result. So, therefore, A inverse is equal to A divided by A minus 1, and in denominator we have A minus 1. If A is equal to 1, then what happens? A divided by 0, then it will not define. But here the given set is R minus 1, means in that set we do not have plus 1. So, therefore, this is defined in the given set R minus 1. So, therefore, it belongs to R minus 1, because it is not equal to 1. Since A is not equal to 1, then if A is not equal to 1, then the element can define for finite values. So, therefore, A inverse equal to A divided by 1, which is belongs to R minus 1. Therefore, inverse law satisfied. If all the laws satisfied, then we can easily conclude that the given set is a group. So, therefore, R minus 1 is a group with the binary operation star, which is defined as A plus B minus AB. So, therefore, this is the proof of the given example, that R minus 1 is a group along with the binary operation star defined by A star B is equal to A plus B minus AB.